Hello, everyone. Today we are going to be looking at homeostasis and feedback. So in your Edmodo, go to the post that says homeostasis and feedback. We have a link for the reading. We have my email where you can send your assignments. And we have the assignment you need to complete. So let's take a look at this thing called homeostasis. So homeostasis is basically your body trying to maintain a steady state or trying to maintain stable levels of certain things. So all of the levels of organization in your body, the cells, tissues, organs, all of that, they work together to try and maintain certain variables within livable ranges for your body. All right. So as such, your body is going to continually monitor the internal environment and make adjustments to try and keep things balanced. So for any given variable, such as body temperature or blood glucose level, there's going to be what we call a set point. So this is the optimum value for a living thing. So for example, body temperature for humans is going to be about 98.6 degrees Fahrenheit. All right, this is the ideal level. So as the body is trying to maintain homeostasis, the value is going to kind of fluctuate around this set point value. All right, these fluctuations are normal as long as they're not extreme. All right. So the spread of the values within which these fluctuations are considered insignificant, so where they're not dangerous, lethal, fatal, that is called the normal range. So for human body temperature, our normal range is going to be about 97.7 to 99.5 degrees Fahrenheit. So how our body maintains homeostasis is we have four interacting components. So we have the stimulus, sensor, control center, and effector. Okay, all of these things are working together to try and keep your body stable. So the stimulus is provided by the variable that is being regulated. So the stimulus is going to indicate that the value of this variable has moved away from the set point or is out of normal range. The sensor is going to monitor the values of the variable and send data to the control center. The control center is going to compare this data with what would be normal values. And if the value is not normal, the control center is going to send a signal to the effector, which is going to be an organ, gland, muscle, or some other structure that acts on the signal it gets from the control center to move the variable back toward the set point. All right, so there is an illustration of this, and here's where we go through it with the body temperature exceeding what is the set point. So the stimulus is going to be the body temperature exceeds its normal level. Here it says 37 degrees Celsius. In America, we use Fahrenheit, so 98.6 degrees Fahrenheit. So our nerve cells in the skin and the brain are going to sense that our body is too warm. All right. So they are going to send that information to the brain, to the temperature regulatory center in the brain. All right. Now, once that information gets to the brain is going to send the signal to sweat glands throughout the body, and we are going to sweat, And as you know, sweat is what helps us cool down. Okay, so we have a negative feedback loop and a positive feedback loop. So the negative feedback loop is going to try and reduce an excessive response, all right, and try and keep it in normal range. All right. So we're going to look at this through body temperature. So with cooling down, the human body's temperature regulatory center is going to be a part of the brain called the hypothalamus. All right, when the hypothalamus receives data from the sensors in the skin and the brain that the body temperature is higher than it needs to be, it triggers the following responses. So first of all, the blood vessels in the skin are going to dilate. So this is going to allow more blood to flow from the warm body core to the surface of the body to try and radiate it out into the environment, radiate this heat out into the environment. So as the blood flow to the skin increases, sweat glands are going to be activated and they're going to increase the output of sweat. So if you're exercising, you don't necessarily, well, you can probably sense that there's more blood flowing, but you can definitely sense that you are sweating because when you exercise, you get really warm. All right, when you exercise, you also breathe deeper, and you usually end up breathing out of your mouth because you can get more air out of your mouth and you can expel more heat from your body that way. So for heating up, when the brain's temperature regulatory center receives data that the body temperature is cooler than it should be, the blood vessels are going to contract to prevent blood from flowing close to the surface and losing heat. The skeletal muscles are going to be triggered, causing them to contract. This is shivering. So shivering is actually your body trying to warm itself up. The thyroid gland may be stimulated by the brain to secrete more thyroid hormone, and this is going to increase metabolic activity and heat production in the cells. The adrenal glands may be stimulated to secrete adrenaline. All right, that's going to cause the breakdown of glycogen, which is the carbohydrate that's used to store energy in animals, or humans. We're considered animals, kind of. It's going to break down glycogen into glucose, which can be used for energy. All right, and then this breakdown process is exothermic, which means it releases heat. All right, I won't go entirely through blood glucose because you get the idea. Is there's a stimulus, it tries to reduce a certain, let me see how it put it here. It tries to reduce the excessive response. So if you're too hot or too cold, or if your blood glucose is not within the normal range. Positive feedback loop is going to intensify a response. So some examples of these are blood clotting and childbirth. I won't go into the childbirth one. You can look at that on your own. So blood clotting. When a wound causes bleeding, the body is going to respond with the positive feedback loop to clot the blood and stop blood loss. So it is intensifying this process. So substances released by the injured blood vessel begin the process of blood clotting. Platelets in the blood are going to start to cling to the injured site and release chemicals that are going to attract additional platelets. And then over time, more chemicals are released, more platelets are attracted, and it results in a clot that stops the bleeding. All right. When homeostasis fails, this is when we get homeostatic imbalance. And this is when, when homeostasis fails, if it's not restored, it can lead to disease or even death. Aging may increase the risk of homeostatic imbalance because the body's systems are not as efficient as they once were. So that's a lot of information. Hopefully that makes sense. Make sure you finish your assignment and turn it in to me.